Hydrokinetic turbines are devices you put in the water that typically spin, and the spinning motion produces electricity, but that also creates a risk of collision with fishes.
I look at a variety of stressors, but my specialty is probably collision risk, which is the risk that animals have of interacting with some of these marine energy devices.
We're going to go downstream first.
Okay.
And we are specifically trying to characterize the fish community that may interact with the turbine while it's in the water.
Yeah.
6 chums.
So we care about all fishes, but some fish are used by humans more than others, and so salmon are the main species of interest. And so in a river like the Tanana, we have 3 species of salmon: king salmon, chum salmon, and coho salmon. This river here, that can include long-nosed suckers, lake chubs, a variety of whitefish species, burbot, which are also recreationally important, and pike as well. And there's always a risk when you put something spinning in a river that it will have some sort of interaction with fishes. And so we're trying to understand what risk a turbine may put fishes at.
Tanana River Test Site here in Tanana. And we've been doing a lot of work on characterizing debris, hydrodynamics, so river velocity, and then we've also been doing a lot of testing of infrastructure, new turbine architectures, new ways to capture the energy in the moving water.
What PNNL people are doing is trying to see if they can visualize or see king salmon smolts, which are about 8 to 10 centimeters long, swimming down to the ocean with this acoustic camera. And then the way to ground truth or verify what they're seeing is by fishing behind their equipment or the beam of their equipment. And so that's another purpose for the fishing equipment that we use.
Oh, there's a burbot in there.
And a little king.
Wow.
So these collaborations are really important because UAF, for instance, has a specialty with a specific test site here, fisheries specific to Alaska, and PNNL, I'm coming with specific expertise based on sensors such as acoustic cameras. Instead of keeping those expertise separate, we're able to put those together. Additionally, there's a large push across the country to combine expertise with national laboratories and universities, essentially our iconic research institutions coming together.
Partnerships are important because hydrokinetics, it's an inherently interdisciplinary science, and so to have the expertise to cover all the aspects of it, you really need those kind of cross-disciplinary partnerships. It's really hard to get all those pieces together.
The benefits of this collaboration and the research associated with, you could start at a very high level and discuss the benefits to the country as a whole. Renewable energy developments to increase and diversify the portfolio of energy that we depend on. I'm standing here on the banks of the Tanana River near the small town of Tanana, and there's advantages there. Everything from the power development that potentially could be used here, or similar development at other villages or other small towns, as well as jobs that could be developed from this locally, as well as bringing in jobs from outside.
My name is Tim McManus. I'm the first chief, and it's a volunteer position. Got about 200 people live here, our school. You know, we got the kids, we've got a boarding school that kids come from other villages and stay here. So I'm very excited about UAF and the collaboration with the Native Council on this project. People have been asking me, what's that thing out in the river, Timmy? Who's fishing? To be able to learn about it and figure out what was going on was a big help.
We've been doing research in the Tanana River Test Site since 2010. As we build this knowledge base, it allows us to not start from scratch, and we can advance the field of clean energy in rivers.